Good morning. You're welcome to our today's lecture. Today we'll take a look at ability 253. Okay, we are still on the topic enumeration and notation. And yesterday we treated the we started the last subtopic under this topic, exponential notation, and we define what an exponential notation is and form back to what numeric form. That's what we discussed yesterday. So today, and we ended this day lecture with operations in exponential notation, specifically addition. So I told you that addition and subtraction, they follow the same principle of ensuring that the power factor are equal before you can do anything along the coefficient angle. So, but the only difference is that when you are done equating the powers, you can now, wherever you see addition, you put what? Subtraction. That's the difference between addition and subtraction in exponential notation. So based on that, I want us to look at this. Or let me solve one or two questions on that. Let me introduce the multiplication and division. So after that, we can now solve questions in all of them. So that will be the end of the topic. So let's look at multiplication and what? Division. Let's look at multiplication and division. So if you have two numbers in exponential form, 3.5 times 10 to the power 3, 3.5 times 10 to the power 3. Sorry. What did I say? 3.5 times 10 raised to power 3. Then you put another bracket. 5.0 times 10 raised to power what? 4. So let's do this. Now, let me use this to Vera. The markers are not mattering. What's going on? Where is she? She disappeared. Where on earth did she go now? All right, look at this. After the class, I will say what I wanted to say. 3.5 times 10 to the power 3 times 5.0 times 10 to the power 4. Now, here you don't need to equate anything. Am I correct? Yes. So all you need to do is you need to apply laws of indices here. Laws of indices here. So this 3.5 times 5 point. These coefficient parts, the first parts, multiply them as normal multiplication, okay? But these powers, you follow laws of what? Indices. Simple. It's not difficult. Are we together? So what you do is you simply do, because of this multiplication, this breadth has not much effect. You can simply say 3.5 times 10 to the power 3 times what? 5.0 times 10 to the power what? 4. You can bring the like terms together. This are in the same form, hope you know. So you can simply say 3.5 times 5.0 times 10 to the power what? 3 times 10 to the power what? 4. So you tackle this with your normal multiplication. 3.5 times 5. 5 times 3 is what? 17.5. Is what? 15, right? Don't worry, let's do it. Let's just follow it step by step for the sake of the weaker brethren. Take it or leave it. Weaker brethren exist everywhere, even in the church. Everywhere in the market, the weak ones, you help them to grow their business. Even here, sir, we also have the weaker brethren. So if I follow the strong brethren, how they are saying 13.5, others won't understand what we got 13.5 from. So come down, let's take it step by step. So remember you said, right? Remember what we discussed on how you multiply decimal fraction. Remember, if you want, you can this decimal point push them aside after you do what? Introduce them, okay? So that you don't get what? Confused. If you like again, if you like, even here now, if this decimal point will cause issues, you move these things here now, they hot. Move it to what? Numeric form. Move it to what? Create another power of 10 from this to 3.5. Hope you know. You can create power of 10 from 5.0, even though 5.0 is 5. True of us. But you can create power of 10 from here. This if you do your decimal movement, remember, if this moves like this, it becomes what? 35 times what? 3 is power what? Is increasing the place value. So it's increasing. So what happened to the power from 0? Decrease by 1. So times power minus what? 1. It shocked them. How much? See, we have left us this. You are still looking at this thing. See where we push them now. I'm trying to express this. I say that you can multiply this out straight. But some people were having issues here. How to handle this point here? Am I communicating? So I am taking it from the scratch. You can decide to move this decimal point. So you can have a whole number you can work with. Are we together? So if you do decimal movement like this is point. This you are increasing the what? Place variable, right? So what happened to the power from 10 to the power 0? To decrease by 1. So you have minus 1. Is it not? Is it not? Yes, then if you move from here, this point is now here. Move it back here. You are decreasing the what? You are decreasing the what? Place value. What happened here? You add 1. It becomes 3 to power what? 0. It becomes 3.5 again. Am I communicating? So having done this, if you like, you may just call this 5 ordinary 5 and do your thing. If you like, this is 5.0. 5.0 is 5. True of us. You can leave it as 5. Or if you want again, you can move it like this. It becomes 50. 50 times 10 to power what? Minus what? 1. Are you there? But avoid creating bogus numbers. Leave it at what? 5. Times what? 3 to power what? 3 times 3 to power what? 4. Then times 5. That should 5 here, right? Times what? 5. So all you need to do is just do 5 times 5. This one is simple to handle. times 3 raised to power what? 13 raised to power what? 4. Times 5 is easy to handle, right? This is one what? 75. So we have 175 times 10. Oh yeah, let's use a lot of indices here. What is this? What minus what? Plus 4. Minus 1 plus 3 is what? 2, right? Plus 4 is what? 6. So you have 175 times 3 is power what? 6. Remember, you cannot leave it like this. You will do your decimal movement, right? Here from here is what? 1, 2. Are you decreasing the place value or increasing it? So what happened here? You add. Are you adding or removing? You are decreasing the words. You are decreasing the so you add. It will increase. So this is what? Plus 1 plus 2. So you add 2 here. It becomes what? 1 point what? Times 3 power what? Where did you miss out from? Hello, please. Where did you miss out? Here. What is there? What is the issue there? What did we discuss yesterday concerning decimal movement? If you want to move this 3.5 now, put it do it. Put 3.5 in standard form. Hello, please. See, there's this problem people have. This thing look easy, and you're here making noise just because you think it's easy. Somebody is asking a question, and you're making noise because you think you know it. It's not charity. Keep to yourself and listen. When did it? Have patience. Be coming down. Even this thing you think you know, you will enter exam hall and feel it. If you're in a class, no matter what you think you know, be following whatever and every step going on there. Don't switch up because you think you know it. Can you move this thing? Remember the reason why I passed through. Left for me alone. I don't need to go through all this step before I can solve this thing. Am I communicating? Now, but I want to tell you how to solve it without punching a calculator or maybe trying to crack your brain. Remember what we discussed yesterday? Now this is 3.5. In multiplication like this, 3.5 times 5.0. If you don't handle this decimal point well, you make mistake. So the best to avoid issues, remove it. Then how do you remove it? You do decimal movement to create a whole number. True of us. You do decimal movement. You move like this from here to here. So move this to standard form. Tell me what will it be? So why asking me again how we got this? Which one are you talking about now? You see it here now. It has always been there now in the question. See it now. I only brought down what is in the question. I'll be coming down from this is what is the question. See it now. Okay, you didn't see this one before. It depends on what you check what of tomorrow. Check your book. Hope you wrote it. Okay. You said what? Sorry. Again, say it again.
If you are to solve this in right,
okay.
You use 17.5.
It gives you 17 point what? Okay, is that what it will give you? Okay, let's check it now. Let's check and say hello. Let's check now. Hello. So what is the issue now? This my song, is it wrong? No. So where is he coming from now? Why do you say 7? Tell me why you said 7. Say the complete answer. 17.5. Is that how I told you to give your exponential answers? I ask a question. Is that how yes, quiet please. Is that how I told you to leave your exponential answer for me? So how does I say you should leave your answer for me? After the first or something. So put it like that now and tell me the answer. Email doesn't mean I'm warning listener. I'm warning you. I keep saying it every day before you go to and say hi. I know what I wrote. Hey sir, what's going on? No, did they have the same value? They have the same value, but don't leave your answer like that. I say bring it down. Bring it down. 1 digit followed by decimal point. Don't give me 17.5. I'm not saying it's not the same value. After all, hello? After all, are you even aware? Let me now show you different values, that different ways to give you the same value. Are you even aware? This is times 8, right? Are you even aware that if you move it like this, 1, 2, right? 3, put a small point here. We move, you add 3 here, right? What do we add? 1, 2, 3, right? So we have 0.00175 times 8 per hour. 3 plus 8 is what? Are you aware that they have the same value? Yes. So what do you mean of this? There must be a form. You should leave it. Even if you keep extending the zeros, they have the same value. But there must be a uniform, a particular form you should what? Be. And that is the form I taught you. Leave it like this. Simple. Don't leave it at 17.5 or 175. Even 175 times 10 raised to the power 6 is the same value. It's not true. Even 1,750 times 10 raised to the power what? 5. The same value. Even 17,500 times 10 raised to the power 4 is the same value. So, which one are you now going to pick? You should have a uniform way you should present it. That's why I say leave it to this form, where you have the first digit followed by a decimal point, then other approximations. Am I communicating? Yes, sir. I keep saying this. People keep failing this exam, this question because of this thing. After now, you see human beings that will go and write for me 175 times 8. I don't know what causes it. I keep saying this now. Listen, okay? Which method? Explain it now. Let me understand. Say it now.
First of all, say that we should make the power to be the same thing.
Okay. Listen. If you make the power the same thing and do your calculation, are you aware that if you make the power the same thing, they have the same value? You are just moving that decimal point here. You are going about quickly. It's your business. No. It's your business. If you are using it and make a mistake because of running a merry-go-round and commit error, I will mark you wrong. I will not pity you. Go direct and solve my question for me. It will make no difference. Do you know why? If you do it like that, you cannot fertilize. So what is the need of doing that? Am I forgetting? Tell me what are you to do fertilize? Remember what we did was fertilization. Hope you know. We brought a common factor. Hope you know. But I fertilize there. And tell me your answer. That's why you brought this confusion. Please follow what I asked you to do. You are free to write what you want to write to. You are free. It's a free world. Hello? You have your pen and listen carefully. Hello, you have your pen and your paper. You can write what you like. All I know is that if you don't give me the answer I need, if you don't follow the step and give me the answer I need, is what you have failed it. Please, let's continue. If you listen carefully. If you take this power, listen carefully. If you equate this power before you start multiplying, doing this thing, you give it the same answer. Then why are you equating? You know, I said this makes more sense in what? Addition and what? So you can factorize, you can bring out the common factor and do your thing. That's the purpose of doing that. If you go and do it, before I introduce it, I stated it clearly that this makes more sense when you are doing what? Addition and what? Subtraction. Because you need to create this and this to be equal. So remember, here is plus. Remember, and here is what? Sorry, now here is what? Plus. Remember, it's just like saying, I explain these things. I don't know why. We are saying 2s squared plus what? 4s what? Squared, for example. Now, you can do what? Bring out the common factor, which is what? S what? Square, and do your thing. Am I computing? You can do that one. Now, if you add the other part, right? Now, but if it's a multiplication, why are you passing through this stress? It doesn't make sense. Because on the process of trying to go, you hear that you can simply multiply and do your thing. Then you go and start putting the powers. You may be doing time only. You can use it if you want to use it too. I'm not saying you should not use it. But on the you may be doing that nonsense and make mistake. I've seen people that, because I too know ITK, you leave questions you ask, you start going to something else. Even in your exam, there are some that could have high score. They started, why are you? Are you pressing me or what? Go to the answer my question. You are doing, at the end, you make mistakes. There's one person, I don't want to call them. She was busy. At the end, she didn't get the answer. Simple thing, answer it and go your way. It's as simple as that. I've told you, you don't need this. It is not necessary to move this equal. If it's multiplication or division, it's not necessary. Because the principle holding addition and subtraction is not the same principle holding what? Multiplication. Just like here. Here, if you have 2x, if you have 2s squared times 4s squared, hello? If you have 2s squared times 4s squared, for example, now, times 4s squared, and if you have 2s squared plus 4s squared, is it the same way you use to solve the two of them? Here you start doing what? Just apply straight and get your answer. This thing we do is just like this. It's not true. Go straight and get your answer. But in this one, you do what? Snare. Snare. Look at the person that took me to this snare. She's doing nothing. If you hear Ojaka, here Meg if you know why, if you hear all the very bad. If you bad, calm down. You're like you ask a question that brought back to almost square one, and I'm here trying to explain, make you understand. You are busy teaching nothing. What's wrong with you? What is the color of your issue? You drag this now. I'm trying to explain things. You are busy talking about. Trying to move this equal, you may make a mistake in one decimal place, you fail it. Something you know. You don't need it. If you do it, you get the answer. But why are you equating powers? After equating powers, then you come down and do the same thing here and the same thing. So why are you equating in the first place? If you can simply multiply and after equating, you must continue from here and come down. It's not true. You must. It's a must. If you try it now, because you cannot factorize, but what is between them is what? Multiplication. You cannot factorize again. You cannot do this time this s square 2 times 4 a square come out. What type of calculation is that one? It's wrong now. It's wrong. You cannot do it. Simply do this times to give you what? 8 what? S what? 8 to the power 4. It's not the same thing. So if after you equate it, you must come back to this and start doing the same thing with this. So why are you equating? Because that one will take almost 1 minute or even up to half page of your paper. It's not true.
Yes, sir.
Then you may be doing it, you may be doing it and make mistake and one decimal place. You'll be like, hey, he marked me down. Nobody marked you down. You will say your time. I'm teaching you how to have questions. Go straight to the question. If you're asked a question, calm down, understand what you are expected to do. Follow it and get your answer full. Please, let's continue. So, I don't know if this one is clear now, right? It's clear. So, leave it at this, okay? It's not 17.5. No. It's 1 point what? I'm not saying it's wrong. It's not the answer. It's not the same value. But there must be a common, I call it stable form. That's what I call it. There must be a common, this thing it should be. A uniform way you can represent it, because like this is something. This, they have the same value. They have the same value. If you move numeric form, they give you the same what? Value. Okay, so this is what we do. This is what we do. What is it called? This is what we do in exponential, in multiplication. Are we together? This is what we do in multiplication. Now, if it is division, go straight. Law of indices also what? Applies. You divide the same way in multiplication, you multiply the coefficient, normal multiplication, we then use law of indices on the what? Powers. When it comes to division, it's the same thing. You divide the what? What is it called? The coefficient, normal. Then also apply law of what? Indices in handling the what? Powers. It's just simple. Don't go and start equating. You may equate and make a mistake. Before you come back to start doing this same thing again, time has passed. And you'll be cried, saying that maybe you may even write everything finish. What do you see like this for the beginning of the bad that I should already there. Am I correct? So why going through that step? That is not necessary. It is not what? I know some people will still switch their mind as I'm talking now. In the exam, they will do the same thing in exam. I have been seeing it in this school. And they will always get the same result. The same answer, the same score. Please. Let's do the right thing, okay? Now, this is, okay, now let's pick a question that has to do with what? Division, and see how it works out. Do you know the first time I heard of the word ITK? That was in my ancestry. My chemistry teacher there. I don't know what I was doing that time. You're looking for, we have to pour it out. Says I am around ITK. ITK. No, why you? Obiamna. And then I later on went back and said, look, and I know the beginning of it. They said, hi. Since that time, it moved across. And it helped me. It helped me. That's how you will prepare. If you don't have get hold of yourself, you will even switch off. That one you know will be ringing in your mind. You switch off to new thing from you, the persons that are supposed to teach you. You block, grab that person that's supposed to teach you. You are busy playing the one you know, and you remember you will not grow. If you know it, calm down. For person to stand in front of you, there's something else you need to grab from the words and get to the one you read. Sometimes you may use that thing the person is saying itself. It's even a way that thing you think you know. Okay? You Jim. Wait. Get out. Get out. Get out of the bed. Get out. So, what's wrong with this generation? What's wrong with you? We are alive. What's wrong with you? What's wrong? 1-0. Oh yeah, go. Manners 0. Hope you saw it. Okay. You don't see it now, right? That wrong, please. If you see after you watch this, let me see. Just fast forward to where, leave like that. Fast forward to where, of course, it's everybody's in it, so no need. No, fast forward to what she did. That's wrong. Let's continue. So, she's not back here. So let's look at what multiplication. After this, I think we have statistics lecture is around. So after this, we end the lecture. 9.3 times 8 to the power what? 5 divided by what? 3.1 times what? Let's put what? 2. Thank you. Now, as I said before now, this is division. Okay? So this is certain as saying 9.3 times 8 to the power what? 5 over what? 3.1 times 10 to the power what? 2. Now, if I may looking at this thing, I already know the answer.
Yeah.
Is that you? But I wouldn't jump like that. That's why I take some steps. The answer is what? 3. But some may not understand why it's 3. That's why I do decimal movement to create a whole number that we can easily divide and get our answer straight. Are we together? Yes. So now, here, remember what we discussed about moving the decimal point, okay? In an attempt to create a whole number here like 3, we move 1, right? Right? Yes. If we move 1, we are increasing the what? Decimal, place value, right? So here should do what? Decrease, right? We minus 1 from here. So we have 93. Is it clear now? Good. Divided by here is 3.1. We do something here. We create 31, right? 3 is power what? 1, which is certain as 10. But let's leave it at that. So we have created a number we can handle easily now. Right? So we can, remember I said that the coefficient part can be divided into normal division, right? So 3 divided by 31 is what? 3 or 3.0. Are we together? So here we have 3 times 3 is power. Remember the laws of indices, right? This is 4 minus what? This is 4 minus what? 1. So this becomes what? 3 times 3 is power what? 3. Are we together?
Yes, sir.
Are we together?
Yes, sir.
Any question? Ask. Is it a must? I don't understand your question. Is it a must? What do you want to? What is in your mind? Tell me what is in your mind. Tell me what you want to do. Is it a must? Is not a question. Before you can say is it a must, there's something else. True of us. True of us. So tell me that in else, not is it a must. Tell me that in else. But what did I say here? This is laughing. But before I tell you this, I made a statement, right? What did I say? I said, by not looking at it, I don't know the answers. But for the purpose of those that may not understand what we are doing, I decided to do what? Move it this way. So I don't think that question is necessary again. True of us, it is not. If you know it, if you can handle this on your own, fine, it's okay, do it. But if I do it here, I'm teaching. If I do it here, some people will be confused. So how do you do that? Will be those that will open to ask question. That will be the next question. But those that not be open to ask question, they'll keep it to themselves. After class, you think that they understood what you did. At the end, they'll be having issues. That's why sometimes I like to go through this process. Are we together? So, with this, I think, unless you have any other question, with this, I think we'll stop here till tomorrow. So, for tomorrow, on a normal, we are supposed to end by 9:30, right?
Yes.
Those going for that event, we should be there by, they should be there at 9 o'clock dot. They should be there at 9 o'clock dot. They should be there at 9 o'clock dot. So, okay, it's 8 to 9, sir. Wow, that's good. I tried today, right?
Yes.
I hit the time. I kept to it. I tried. Why are you so enjoying that thing? No, let me end it. I'll tell you what I want to say. Now, anyway, let's end the lecture first. Thank you very much for your attention. See you next time.
Yes.